Factorise fully 3x squared minus 12y squared. Whenever a question says factorised fully, we know we're going to have to do more than one step of factorising. The first step in this question isn't too difficult. We can see that we can factorise 3 outside of the 3x squared and the minus 12y squared. Let's just double check that. The 3 times the x squared is 3x squared. That works. The 3 times the minus 4y squared is minus 12y squared. That works. So we've done the first stage of factorising. We now need to do the second stage of factorising. So factorising this is the difference of two squares. If you're a bit rusty on the difference of two squares, let me just remind you. If I have a squared minus b squared, that can be factorised to be a plus b times a minus b. And let me explain why. Because we'll have the a times a, which gives me the a squared. We'll have the b times minus b, which gives me the minus b squared. And then crucially, we'll have the a times minus b, which is minus ab. And we'll have the b times the a, which gives a positive ab. And these terms here cancel out, which is why there's no middle bit here. It's just simply the a squared minus the b squared. So as another example of that, let's say if I had 4x squared minus 9y squared. That's the difference of two squares. I can rewrite that as 2x plus 3y times 2x minus 3y. Because the 2x times the 2x gives me the 4x squared. The 3y times the minus 3y gives me the minus 9y squared. And the two terms, if I multiplied them out in the middle, I would have a 6xy and a negative 6xy, so they would cancel each other out. So let's use that idea of the difference of two squares here. We're going to have an x plus 2y and an x minus 2y, because the x times the x gives me the x squared. The 2y times the minus 2y gives me the minus 4y squared. And the two terms in the middle will cancel each other out. So that is my fully factorised form.